Welcome, everyone. This is our inaugural podcast. We're calling it The Next Big Thing. We're going to focus on numerous thematic-oriented topics. And when we were kicking around the idea of doing a podcast and then thinking, what thematic topic should we start off with, given it's April of 2023 at this recording, we felt no other topic would make sense other than artificial intelligence. It's a huge focus this year, getting a lot of attention. Certain stocks are delivering strong investment performance. Certain strategies are delivering strong investment performance, at least thus far. So all of those things came together to lead us in this direction. Now, at the start of every podcast, I will have to say the following. To clarify, the views and opinions expressed in this podcast are those of WisdomTree and, in this case, the Consumer Technology Association, and are subject to change. Anything we present in this podcast is not intended to be relied upon as a forecast, research, nor as investment or tax advice. The information and opinions expressed in this podcast are not a recommendation, offer, or solicitation to buy or sell any securities, and reliance upon them is at the sole discretion of the listener. Please remember, past performance is no indication of future results. So since that is now out of the way, we can introduce our inaugural podcast guest. His name is Brian Comiskey, Director of Thematic Programs. So big title and perfect for, again, a thematic-oriented podcast. And he works with Consumer Technology Association. Brian, welcome to the show.
Yeah, well, Chris, it's an honor to be the inaugural guest. It's an honor to be here. And yeah, I'm Brian Comiskey. I'm the Director of Thematic Programs at CTA, and I'm really looking forward to discussing AI trends today.
So as we dive in, one of the things I think the audience would benefit from is Consumer Technology Association. What's the background of the organization? Just to give people a sense. You know, obviously your title is Director of Thematic Platform, so it clearly indicates a focus more broad than just AI. But then, of course, within that, the focus in AI might be near the top of the list, and ultimately the way in which CTA gets its information and is able to interface with the ecosystem. I think it's quite interesting, but I'd love people to understand that better.
Yeah, of course. And I think we start with kind of a top to down approach about who we are a little bit. So CTA, the Consumer Technology Association, we're North America's largest technology trade association. Our members are the world's leading innovators. So from global brands all the way to those startups, we support about more than 18 million American jobs as a result of it, sitting as a nonprofit trade association. You probably, for folks listening, and Chris knows this about us quite well, most people know us best as the owners and producers of CES, which is one of the most influential tech trade shows in the world. I'm sure we'll talk about it a bit later as it relates to what we saw with artificial intelligence, but really CES is the proving ground for breakthrough technologies and global innovators, and it's where most big brands do their business. We just had a great show in January of this past year. We're going to be returning to Las Vegas for the show on January 9th through 12th in 2024. So hopefully looking forward to seeing some folks here. If you've listened to this episode, let me know, and I will gladly catch up on you on the trends that have changed over the past year since the episode. But that's a bit about the organization as a whole and our show. What does it have to do with thematic programs? Why are we in the thematic program space really as a nonprofit trade association? And really, when we think about CTA's role, right, is innovation stands at the core of our organization. It also stands at the core of our thematic program. So whether it's the evolution of cybersecurity into a digital utility, digitalization of healthcare, or just the significant transformation of artificial intelligence in the last year, our CTA NASDAQ Partner Thematic Indexes really focus on identifying the trends and corresponding companies pushing forward long-term innovation in both the United States and abroad. We take a global focus to this. Really, in a lot of ways, our value prop is defined by four key areas: innovation expertise, what we're seeing in terms of the space through our members, as well as the show. That lends into a broad perspective. As I said, it's not just the global brands that that are publicly traded. It's the startup space. We're an established research presence as well. Our research department, where the Thematic Program sits, has been around for about more than 30 years, bringing established presence to the global tech industry. And then we have a global reach. We've had over 100 countries represented at CES this past year. So really what you see at the end of the day is a thematic program consisting of expert analysts from our technology and standards division that pioneer standards such as airplane mode, as well as the first AI standards in healthcare, our research team conducting surveys on behalf of members and consumers, as well as our business intelligence team that puts out a pretty robust semi-annual forecast. So pulling that together, we have about 150 years of tech experience that we're combing through. And I have the pleasure and honor to work with that team and in partnership with NASDAQ on a portfolio of 15 indices today. So it's been a lot of fun.
And Brian, if we're thinking of Consumer Electronics Show, Las Vegas happens every year in January. What's like a rough guideline? I think I heard a statistic once that it's like over 1 million square feet of exhibition space. How many people also tend to go to this thing?
Yeah, of course. So this was a banner return year, if you will, for us, I think, right? The pandemic, we switched to a hybrid show in 2020, for CES 2021, I should say. We managed to get a show in right before the outbreak. But prior to, we had about 170,000 attendees in the past. We were really excited because this year really kind of marked the return year. We hit around 120,000 or so attendees back in person for the first time. We had a few thousand exhibitors as well, as I said, from countries all over the map. So when you go there, as I said, I'm glad you said 1 million square feet. I think it's 2 million is what It is now. But basically, Vegas is, and why do we do Vegas? Vegas is home to some of the largest convention centers and show spaces. I think they have like 6 or 7 of the top 10 in the United States. So as a result, they have the infrastructure to host this show, where we're at the Las Vegas Convention Center in their West Hall, North Hall, Central Hall. But we also have a whole other campus at the Venetian in their massive expo center, as well as a third location at the Aria just for our what's called C-Space, which is our content and marketing professionals talking about how tech is advancing their space. So it's one of those, I always say it's a big show. I always knew it was a big show, but when I first attended it, which was CES 2020, it's always bigger than you think. That's, I guess, the best way to say it. It's always a massive show, and it's a ton of fun where businesses, exhibitors, everyone's just getting together for the fun and innovation that technology brings.
And something I'm glad you mentioned the first year that you were there, because one of the things I was thinking, I've personally not been myself as yet, but I imagine that if you're thinking of a topic, and obviously today we're here to talk about AI, so we'll use AI as our example, and we'll say, Brian Comiskey shows up in 2020, and the focus that the companies working on AI are taking in 2020 might look a certain way. And then when you get to that hybrid show in 2021, maybe there's a few new things or other things. And then you get to 2022 and 2023, and you kind of keep seeing potentially different types of technologies within AI being pushed. And as you're coming off your 4th show, Brian, I'd love to hear a sense of the type of evolution that you've been seeing in AI as you've attended the show each year. That's
a really great question. I usually people are like, oh, what's the coolest thing you've seen? And I'm definitely going to talk about that. But when you think about it, you're the first person to ask the long view, what it's like now. And you're right, I have 4 shows under my belt, which time flies. But when I think about when I see artificial intelligence, when I first got to the show floor, I think in 2020, we were still in kind of that initial buzz of what AI is starting to do across the board, maybe in some other application areas. We were familiar with natural language processing was, pushing forward data analytics to a degree. It was using it. I actually used to contract supporting CTA in a role for checking media coverage, and we were using AI to a degree with it. It felt very enterprise, but 2020 felt like before the pandemic really changed some of our focus, right, to maybe more cloud and entertainment and streaming. AI felt like it was starting to make this push of, well, now the consumer can see it a little bit more, or it's underpinning everything. Over the next few years, as I said, we pivoted. We started thinking about, okay, how's the cloud supporting hybrid work? How is streaming keeping us entertained while maybe we're in lockdowns? But AI is still underpinning all of this in the background, and you hearing it and seeing it with some of the exhibitors on the show floor where they're talking about, well, we're using AI for upscaling in terms of the quality of your streaming fidelity. So, we can use AI to get you to that 4K scale, even if it was not shot in 4K, if you're watching like something like The Mandalorian. So it's really talking about in the background. And again, it's underpinning everything. What starts to become clear over time, and how we started talking about it when we made our return to a hybrid show in CES 2022, was AI really has always been in horizontal technology, but it was just quite clear where it's sitting underneath so many different outputs and applications, increasing performance, increasing efficiency of a variety of other technologies. We think, a lot about the cybersecurity and the cloud computing element, but you're starting to see for consumers, okay, how is it impacting the ability of, again, your streaming quality? How is it helping my smart home? We saw a lot of people upgrading their homes, for example, during the pandemic. If you're going to spend so much time there, you're going to put a lot of upgrades into your security elements. AI is starting to incorporate and make these devices smarter, work across. Flash forward to this show, and I think the combination of a few factors. ChatGPT had just released the third model right before the show, and where we started to see horizontal technology being talked about more than ever, because we still have a lot of things that the pandemic revealed to us in terms of how we operate as a society. One of them is we have workforce gaps, right? We have something about 2.5 quintillion bytes of data is produced each day now. That's 2.5 followed by 18 zeros. So when you think about it, that's so much data for more than us to process as humans. We have these gaps here in the workforce, and we have AI already underpinning our consumer tools. There's this recognition that AI has really emerged not just as a horizontal technology anymore, but it's a digital utility. It's a technological necessity for companies just like water or power to use to provide their services to everyone. And we saw that with how it went across the show floor. We saw AI-powered ovens. We saw AI-powered TVs, but also upscaling GPUs from NVIDIA. We had fatigue battling watches that you can wear on your wrist that AI-powered. So it really appeared in so many different applications across the show floor. And that is really just the beginning. And there's another example when we talk about generative AI from the show floor that I'm looking forward to diving into a little bit, but I'll pause there.
No, and Brian, you kind of alluded to it. So for the benefit of myself and the audience, I now have to ask. I mean, I think the world thought that ChatGPT was basically the coolest thing. If you look at such statistics as the time to 1 million downloads or 100 million downloads or the average monthly website visits, what they've been able to achieve with that application has been nothing short of incredible. But for those 120,000 people that showed up to Las Vegas back in January, I'm just wondering, are there any surveys? What would they have said was the coolest thing that they might have gotten to see? I mean, you're talking about fatigue battling watches and whatnot, stuff that, in the regular marketplace we haven't seen yet, whereas we've all seen ChatGPT. It's accessible far more broadly.
Yeah, no, I think about that where it's so ChatGPT certainly everyone could see. And so let's take a step back. I'm happy to say, like, generally outside of AI, what were the big CES? Like, what did we see that was pretty major? We saw a color changing car that was pretty exciting to see in person from BMW. Literally, it can change not just from a red to a green car, but it could do patterns now. So you could have a plaid car one moment, and a
Like a
solid black
chameleon
car.
car, basically.
Yeah, a chameleon car. And here's the kicker to it. The it's the BMWs. They showcased the concept to it when they introduced it. Had Kit featuring on it because it has AI voice capability on board. So here's AI factoring into this car that was pretty major and whatnot. I mean, we also saw a lot of vehicle innovation. The new West Hall sees just so much on board, and you heard people, instead of saying car, they were saying software defined vehicle, because so many vehicles have AI underpinning them, other capabilities. One of the cars I saw, solar powered car, so the roof is entirely a solar panel, so it's got this nice two-tone black and white model from Lightyear. But we also saw things like digital health glasses from SK, that you wear them, and if you suffer from epilepsy, it reads the data from your biometrics while wearing these glasses to create a predictive model that can predict possibly when your next seizure episode is, right? So just thinking about how much digital health even leveled up, and there's AI underpinning that too, right? I said there's a predictive model within it. But when we think about a generative AI, something that really captured me was there's a company called Deep Brain out of South Korea that was showcasing a few of their ability for artificial intelligence to really improve digital avatars or digital humans in a way. They actually had a fully digitized Howie Mandel that would answer questions and offer jokes, essentially like Howie Mandel, mind you, and whatnot, which was incredible. But here's where the applications get even more amazing. Where one was something out of science fiction called Rememory, that they offered, which was if you are elderly or you're going to pass on, you can go in and record yourself, and Rememory basically recreates you afterwards to be able to handle chats for essentially therapy for families to like get closure moving on. So a very different application of generative AI. But the other one that was really surprising was Deep Brain had been using their technology to had been licensed out to the current president of South Korea during his campaign. He created deep fake videos, essentially out of generative AI, for his campaign using it. And in it, actually, they found that he was more popular with younger voters as his digitized self that was younger, never even stepped foot to record these ads. These ads were just built off of his campaign speeches, and he won election, which kind of opens us up into a new territory when we think about what, if generative AI's whole focus is AI that can generate novel content, what does that mean if it's already influencing our politics or even our ability to cope with loss? So there's some quandaries here that we have to consider.
I mean, as you were describing that, Brian, I felt we were this close to going down into a Black Mirror episode or what have you. It's quite fascinating, the intersection between art and reality from time to time, and some of those things there were right on that sort of interesting boundary. I think we've set it up. We've got to dive in. Generative AI. The first thing, Brian, as someone that is looking at the space all the time, doing the research that you've done, recognizing that even if as a general society we're hearing about generative AI in 2023, but a lot of these things, they get worked on in anonymity for years and years before the general person appreciates the effort. What is generative AI in your view, and is it really this gigantic leap forward, or do you see it as sort of a natural next step relative to what we might have been talking about in 2017, 2018, etc.?
Yeah, as I said, I'll go back to that baseline definition and expand on a little bit, right? So generative AI refers to artificial intelligence that can generate novel content rather than simply analyzing or acting on existing data. It can make something new, which is why I think the popularity has risen, because consumers have been able to get their, and everyday, I should say, not just consumers, everyday people can get their hands on the applications of it. I think that's what's popularized it so fast. I know I actually have I usually in the past, I was not one to go in to experiment with OpenAI, to be frank, or I actually have only looked at Microsoft's Bing AI powered search. But what got me was the Dolly generator, the art generators on OpenAI, where, you know, you can create whatever data you want. And I, like, for me, I have 4 cats. So I was able to create like a photo of like our cat as a Buddhist monk, enjoying enlightenment. Right. And it came out surprisingly good. I'll send it to you later. But the thing about it though, right, is the popularity, there's a hype to it naturally because it feels more tangible than a lot of other AI advancements, which were, as we're talking about in the long view of CES, felt like they were underneath everything. Okay, yeah, I'm viewing a much better upscaled piece of content from an AI output. 75% of my recommendations on Netflix or Amazon in general are probably actually from an algorithm pushing me to at least help me get to the better thing I want. But with generative AI, I do think that some of the hype has reality with that idea of novel content. We jump to AI art because I think that's what we can see easily, but I think we go to what are the applications that could really help today, coding and whatnot, making it easier for teams that might not have coding expertise could happen here. You would see drug discovery be one, where the ability to start simulating and creating hypotheses of possible combinations in biopharmaceuticals to create novel treatment for disease. And all of that comes down to, in our eyes, synthetic data being important, right? And when you think about that, right, this is data that's not based on a life event, not based on anything that, you know, has occurred and has been observed to record. This is taking a little bit of base off real life to synthetically create new data that can train models faster to adapt and innovate and offer cutting edge technology and insight from artificial intelligence. That is incredible. Because then you're talking about the speed of adaptation just getting further and further. So even though, yeah, I think there's always the tendency to maybe overhype a new technology, there are some real groundbreaking things there. And again, synthetic data kind of is behind the scenes, not getting as much hype as personally I think it's getting, but it's important.
You mentioned drug discovery, and it's crazy to consider that I think it was late July, early August, that it was announced last year that DeepMind, with its AlphaFold program, had solved, you know, the 50-year or so protein problem, namely the fact that if you go to the various websites and you actually look at a 3D depiction of what a protein really looks like, the idea of predicting what the shape, the folding would be, it's nothing short of insanity, because these aren't like, you know, simple little things. These are some of the most complex. I was probably looking at a simple one because in my inexperience, and it looks like one of the most complex, randomly organized designs I've ever seen in my life. And yet, you know, you come up with this system. I think they said they sequenced, at least at that point, 214 million of these, most of them having to do with the human biome. And then you then say like 35% or so are done at an accuracy level at or near X-ray crystallography. And then a few months later, pretty quietly, in my opinion anyway, Meta comes out and indicates that they've sequenced or got a prediction model that works a bit faster, but it can do 600 million of these proteins. So in essence, along that thread, and I wanted to pull out the drug discovery thread a little bit more, just because of all the things you mentioned. That one, Brian, to me, tells a story that could be paying dividends for quite some years to come.
Yeah, I to be frank, I think it's already paying dividends. When we think about, I mean, we talked about this in the context of CES and all the changes that we saw and pivots, you know, through the COVID-19 pandemic. AI was employed actually by Pfizer to run vaccine trials and expedite distribution. And then it was also used throughout the development process by other companies to really start to map out and discover, okay, what is the right combination here for drug trials? That's really, in a lot of ways, the tip of the iceberg, but you're already seeing here is AI helping with vaccine development and delivery and exposition. There's a difference between development and discovery, of course, right? But when we think about what is AI going to do in terms of small molecule drug discovery, there's really four ways, right? You get access to new biology in the sense that it really can create novel ideas of what the structure of these platforms look like. By the way, I do not have background in healthcare or biopharmaceuticals. So I am like you, Chris, when I see some of these structures in my head, I'm like, this is the most complex thing I've ever seen. Yeah, I'm sure a doctor would go, that is the easiest thing in the world, and whatnot. So this is me trying to keep my AI hat on while balancing it. But as I said, new biology or it's improved or novel chemistry is also what goes here, right? How do we improve our chemistry research habits around our drug discovery and development? But that also leads to better success rates is really your third way that drug discovery is going to, and with AI, right? You're not going to have longer trials and error because that's the scientific process is defined by trial and error. But what if you can shorten that a little bit? And the more efficient you make it, you get to the fourth element, which is probably pretty critical if you're running an enterprise or a pharmaceutical company, which is how do we get to these discovery processes faster? And so not surprisingly, you're starting to see more partnerships in the space between AI companies and biopharmaceuticals. Like, for example, we know that Illumina is doing a partnership with AstraZeneca, for example, where Illumina is offering a lot of their AI capabilities to help improve drug discovery and development at Pfizer. That's just one example of so many now.
It's quite an interesting time for the generative AI, but something that you got me thinking about, Brian, was sort of this idea that at various points in time, because we're sort of on this timeline, and it's sort of like the prior experience and what you've seen sort of dictates how you view the current set of realities. And I remember when we started at WisdomTree working with Consumer Technology Association around, say, 2018, 2019, we were predominantly talking about robotic process automation. Mm-hmm. And then we were talking a lot about computer vision and then in particular how it relates to autonomous vehicles and advanced driver assistance systems. And then, you go down the path and you're starting to see some coding assistants that in some cases relate to generative AI, in some cases may relate to other things. And so you have these fits and starts of innovation, but you just get this sense, and tell me if this is even accurate, you get this sense that AI is advancing seemingly across many different fronts, but sometimes where our collective societal attention goes, like right now it's on these gigantic foundation models, large language models that power things like ChatGPT, GPT-4, Bard, and the like. But it wouldn't be the case to say, well, autonomous driving is on pause right now, or robotic process automation, they're just not doing that anymore. It's just that everything is still advancing, and what captures our imagination and our excitement sort of ebbs and flows from time to time.
Well, that's a beautiful way to put it. When I think about it, right, I really like that. You captured that it's a horizontal technology, which is what we were talking about at the start of it. But you're right, where the ebbs and flows really do. It's where the attention goes. Like, where is the overall societal attention moving towards in the space when it comes to, in terms of the AI sector?
So Brian, I feel like we'd be remiss to not talk at all about the hardware part of the equation. And I mean, you alluded at the CES, and I'm sure from year to year, people are probably going specifically wondering what will be unveiled by the likes of the NVIDIAs and the AMDs of the world, because without some of these cutting edge semiconductor chips, some of which are so powerful, certain countries aren't even allowed to get them. The types of AI, the types of processing that we are discussing to power some of these applications, they're just simply not possible. But at the same time, I know I've learned in the last, say, 4 or 5 years that the ecosystem of semiconductor development is anything but simple. And I feel like when I started this journey, you weren't seeing as much in terms of the big companies deciding to design their own chips, whereas now Apple, I know a few years ago, was big news. They cut Intel sort of out of their specific supply chain, as well as you sort of learn about electronic design automation and the importance of companies like Cadence or Synopsys, as well as chip fabrication, and that there's so few players, one of which being Taiwan Semiconductor, that even is able to make the chips that power everything that we're talking about. So I'd love to get your big picture view, Brian, on sort of the state of the semiconductor space and potentially some of the things that you've been seeing there.
Yeah, I think that's a really good question. And also this is a nice parallel from your previous one where we talked about there's so much innovation occurring across many fronts. We tend to focus on one. So when we think about the artificial intelligence ecosystem in general, to kind of start at the top, chips and sensors, make up really one key leg alongside platforms. You mentioned RPA in the discussion being important. You take chips and sensors, whether that be AI chips, neuromorphic chips, we'll dive into those a little bit more shortly, combine it with platforms. That's how you get to your ideas of simulation, which includes things like generative AI or conversational AI, gets you to data processing, and also gets you to autonomous systems like robotics and self-driving vehicles. So when we look at the chip and sensor space, the innovation continues to just be astounding on the hardware side, right? We're now seeing, and you and I have talked about this before a few years, you're starting to see AI go into chip design. The novel generative AI use cases is likely to be, how do you improve chip design for through artificial intelligence? And when we talk about it, it's not what type of chip process that we're occurring. I mentioned neuromorphic, which means trying to get chips that simulate the human brain in terms of the activity that's occurring in this space. And so what does that translate into when we think about, well, let's start at the space. Well, how do you get these chips? How do you make semiconductors in the first place that power the whole AI ecosystem? Well, we know that we're in an era where a lot of it occurs in Taiwan. And I know we might talk about it more and whatnot. There's geopolitical concerns between the United States and China, but we know that there's a lot of investment now. That's into more semiconductor fabs. That's one of the key areas to watch when we dial down before we even get to innovation. We know people are investing more in semiconductor fabs because of the recognition of their importance strategically. And when I say strategically, I'm not just saying, for the US government or the Chinese government, et cetera. Yes, that's important, but also just for enterprises and for consumers. These are critical components to so many outputs, not just for AI, but for in general, for most of electronics. We're looking at about $500 billion in spending on 84 different fabs by the semiconductor industry by 2024. And that's in the United States. Certainly, we've heard stories TSMC is going to be heavily into Arizona, but we're also seeing that investment occurring in the Americas at large, as well as Europe putting a lot of focus, but also China is increasing their own capabilities, and Japan and Korea are starting to flesh that out, because a lot of that concentration occurs with your TSMCs or your Samsungs, but starting to see some of these other players globally, at least if the two of them are expanding their footprints abroad, but other companies starting to grab that space. And that really allows for just a greater flexibility when you have more fabs for more innovation at the end of the day, right? You can make certain fabs be targeted on your more general sort of larger chips versus the cutting edge ones that are your 2 nanometer sort of size. So really looking at it from that regard, we're just going to expect to see a lot more innovation again in AI designed chips that have AI capabilities from the get-go. I'm glad you mentioned companies too, where it was big news when Apple decided to make their own chips. But one of the company that we're watching in the self-driving space around AI is Mobileye. They're now designing their own chips called the IQ, which is AI chips specifically derived for self-driving vehicles, and not just for mobile eyes. Their intent is to sell that to other companies and licensing that out for the whole ecosystem. I mentioned neuromorphic, but then when it comes to sensors, you see things like computer vision, parallelism, and in-memory chip design. So the ecosystem only gets more complex, more focused in some ways for specific outputs, but at the same time, you're seeing innovation being made really for all.
So, Brian, I'm glad you touched on sort of this idea of different types of chips, different types of capability. I noticed you said things like, neuromorphic chips, 2 nanometer. I personally think that in the iPhone model that I have sitting right next to me on this desk, I think it's a 4 nanometer. I'd love to get an impression, just in case anyone listening is sort of like, what is all this jargon and why is it important? Because sometimes, in the case of China, you hear they might be dominating, the 14 to 28 nanometer size segment, but they don't have certain capability that could get them to say the 3 or 4 nanometer. But then you sort of also think in the back of your mind as a regular person like I am, what's the real difference? Why do you need 2 billionths of a meter, a couple of atoms separating the units of silicon there? I'm just curious to help people have a better impression of the vast variety of some of these chips.
Certainly, yeah, and that's the fundamental question at the end of the day when you're thinking about chip specs and what they impact. When I have to describe this, if I'm talking to my family and they're asking me about, I keep reading about these semiconductors, and this sounds like a problem with China. That's my favorite. This is the general question. Why are they important? When you think about the nanometers for what it means for computing processing, and these sizes, right? 2 nanometers is a much smaller chip than a 15, right? When the transistor size, so that's what we're talking about here, the transistor size on the chips, when it is smaller, there's less distance between them, right? So there's less distance between a 2 nanometer versus a 14 nanometer. Less distance means the electric signal will travel faster, making the overall performance of the CPU faster. Why is that? Because when you're looking at the smaller size, electrons are traveling a less distance, and that means that you're shedding less power in resistance to do the same work. It takes less resistance to get the same amount of work done. So when you're thinking about that, okay, then why wouldn't I want all my chips to be 2 nanometers, right? Or a smaller size. One, it's very complex to make them, and not everything that you're using from an output perspective requires chips to be at that level of CPU. So from an efficiency standpoint, from an order lead time perspective, how much lead time you need to provide an order to a fabrication site to make your semiconductor, you might, if you're putting all the ducks in a row for 2 nanometers, you're using just this very specific limited amount of equipment and not using existing equipment that we have. So for things that require a little bit less CPU, that larger size is fine. It will get the work done for you. In fact, pandemic led to a shipping shortage, considering how many electronics were just being ordered. You saw a downside, especially in the automotive market, where automotive sales going down meant that they initially cut their orders. And that kind of created a pile-on domino effect of companies trying to figure out what their lead times were. So you started seeing actually the rollout of some cars using older chip models to make up for the gap because it got the job done. It can compute what you needed. And so there was a realization, I think, a step back in some ways, probably for the industry from a supply chain perspective, saying, do we need this specific nanometer size chip for this output, or does another one, will it do? At the same time, I would be remiss if I didn't mention that why does it keep changing? Why is the number of transistors on a microchip changing? There's a concept called Moore's Law, for those not familiar, that states that the number of transistors on a microchip doubles about every 2 years, though the cost of computers is halved. So in this case, right, when you're looking at this, you're innovating how many transistors are on your chip size and it helps at least with the reduction of resistance and efficiency lost. You're eventually reducing the cost of your electronics. So that's why you want to keep innovating in this space. And it's a question some people ask: is Moore's law still valid? We're at 2 nanometers is what we're about to hit. Can we get to 1? Right? And so how do you get smaller and smaller? And that's going to be the fundamental question, which led to why we talked about different chip design in the first place, right? When we're thinking about neuromorphic, we're thinking about our chip transistors operating in a different way than we're very familiar with. When we're thinking about quantum computing too, chips are going to have to operate in a different sense beyond just binary understanding. So I think you're going to see complementary laws start to emerge alongside Moore's law. Is probably the best way to put it.
They already start to mention Huang's law, Jensen Huang over at NVIDIA, one of the founders there, having to do with sort of training, the speed with which or the cost with which you train some of these gigantic models. And something I was thinking, Brian, as well is, and I know we've touched on it over the years, you sort of have the parallel evolution of something like the Internet of Things. And you think, okay, in the pandemic, people might have been attracted to different types of devices because they're sitting at home and they're thinking, oh yeah, that looks interesting. This looks interesting. They're getting potentially some government stimulus checks, and they're potentially upgrading some of their electronic stack. And in the end, what you end up with now is all these different connected devices. But at the same time, and it relates to the chips, because you think of a data center like an Azure or an AWS or a Google Cloud, and you would imagine, okay, that's where the cutting edge needs to be. But at the same time, if you've got the smart refrigerator, the smart thermostat, the smart washing machine, you may not need an NVIDIA A100 directly in that device. But at the same time, you're kind of wondering, is it appropriate to think of it as edge, meaning the AI is done right there, or is it appropriate to think that there's this transmission that's always going on where data is already being or always being sent to the cloud, and that's the only place where AI can occur, and then the inference sort of comes back and communicates with the device. So sort of this difference between edge computing or cloud computing being really an interesting driver of certain different activities and certain speed as well. Like if you think of something like autonomous vehicles, there are probably certain scenarios where it's got to happen on the vehicle for safety purposes. You can't be saying, well, the weather's bad and I can't get a signal, so we don't have access to the Azure compute stack, so we just can't drive the car at this moment. That's obviously not going to work. But this idea of sort of cloud-based or edge-based, I personally think is a big one.
Yeah, and I think the lines are only going to continue to blur when you think about how many devices are out there, right? I think the autonomous vehicle example is pretty critical. There's a reason they kept saying software-defined vehicles, SDVs, instead of cars, right? Understanding that, especially if you're trying to do a self-driving model, yeah, you're going to require at this stage, at least from our understanding, right? It requires sensors, cameras, LiDAR, radar, all these things. And you do need the cloud to offer some of those capabilities to define and be able to help process the autonomous capability, just the sheer amount of data coming in. But at the same time, you have to make those considerations that you just outlined, right? Well, what if the weather's bad? What if the signal's cut? What if, and this is a concern that I tend to think of as someone having worked with experience in cybersecurity policy. What if you're hacked? What if you can't and get over? So what can the computing on board a vehicle do to provide that data? And so I think that's a consideration that's going to be, I have to agree with you, is going to be critical to watch over the years, where that AI is going to have to occur in the device itself in terms of being able to compute these datas, in conjunction with a larger cloud stack off premise, but also how can it do it independently? So these considerations of how these devices will have to be from a standpoint in terms of how they operate with one another independently. And that's something I'm glad we also talked about connected device increased use in the home. There was a lot of people getting smart home devices that have AI on board, but if you've seen any adoption, a lot of the biggest complaints is the friction between device usage, right? A lot of people don't necessarily think, oh, because I have this device from this one manufacturer, they might get all their devices from the same one, or they're going to look at cost, right? They're going to look at what's the cheapest, what actually has the features I want, but then how are they communicating? How is that data being communicated in the AI processes? So we were really excited to see, for example, the launch of Matter, which is an open source connectivity standard for smart home and Internet of Things devices, which is trying to improve their compatibility and security. It's royalty-free standard, by the way, through developers, manufacturers. CTA has been a big proponent of it. What I'm excited to see is, okay, we have these standards around compatibility and security. Where does the AI compatibility and AI security stand into it as well? Because that's what makes these devices so remarkable for our home, right? Our smart home cameras, our smart doorbells, and the like.
And it's interesting to sort of, as we think about sort of what we've been able to cover so far, again on this inaugural episode of our Next Big Thing podcast here. We've alluded to some software oriented things, generative AI. We've gone into certain elements of semiconductors and chips. We recognize that there's only so much you can do if you're not doing an 8. And unfortunately, this episode will not be 8 hours in length, so we won't be able to go into full detail and granularity on everything. But Brian, as you start to sort of bring it all together, in general, you sort of have the growth stocks, value stocks distinction that the market makes, and a lot of the AI oriented things end up on the growth side of the ledger. But then as you sort of start drilling down, you've got your users of AI. You could think of your ByteDance / TikTok, your Netflix that we referenced. Companies that clearly use AI for some form or another, but that's just a supportive business element. We talked a bit about software and hardware already, and then you sort of wonder, how should a person think of some of these giants, whether it's your Teslas of the world, your Microsofts, your Amazons, where they're some of the, like in Amazon's case, one of the largest deployers of robotics in the entire world. And yet you then say, if my focus is robotics or my focus is AI, you're really getting an e-commerce platform and seller with a slice of AWS and a slice of certain other things, even if you're sitting there excited by the robotic prospects and certain elements of AI. So when you look at some of the largest companies in the world, be it Amazon, Apple, Microsoft, Alphabet, what have you, what gets you excited in particular about those, recognizing that sometimes, they're one government regulation away from, let's say, underperformance in the market?
Yeah, I look at it, and I think this stems back to how CTA alongside NASDAQ views the AI ecosystem when we work on when we think about our product, our index product, like the NASDAQ CTA Artificial Intelligence Index, is we have 3 categories. We have enablers, which I think we've talked about a lot, right? Those hardware companies, specifically chip designers, some of those fabs that create, that enable artificial intelligence innovation. And I'm using that word innovation very clearly as we go to engagers, which are those that are using AI in their full product offering and service. You think about RPA platforms like UiPath. You think about companies like Black Knight in the past that uses AI in their outputs. But then what you're touching on is really this last category when we consider it, which are enhancers in a lot of ways. Who's using AI as a value-added service? But in this case, with that value-added service, they're promoting the innovation in the AI space, right? Amazon's a really good example to highlight here, right? Because an e-commerce company off the top of their head, I think it's, they still derive more than half of what we would call thematic revenue from e-commerce. But I said earlier, it's something like 90% or more of the shopping services that you buy, that you're selecting, is an AI algorithm underneath it. For them, AI is underpinning all of the innovation in the other spaces. AWS, cloud service provider, right? Massive. So many people adopt it. AI underpins the ability for it to operate more efficiently And those innovations that they're making as a large cap company then trickle down to a lot of the other companies that are trying to innovate in this space. And that's what gets us excited around things like Microsoft. It gets us excited around companies that maybe are on Mobileye. In our view, they're developing a chip, so they're very in the AI space. But if you looked at like any other self-driving company in the space, they're probably incorporating some form of artificial intelligence underneath their service, like Tesla, for example, with their cars and their focus on full self-driving. There's an artificial intelligence component that really is adding a value to their service. So when we look at it, is, you know, it's regardless of size. At the end of the day, it's all about what does the innovation mean for the space. When we think about companies in the past, like a JD.com is the first to roll out autonomous delivery vehicles during the pandemic at scale, right? AI was underpinning that. Or we'll even go back to the CES show floor. Actually, let's bring it home a little bit. John Deere, ag tech company. We think agriculture, but at the same time, they've won CES Innovation Awards for things like their See and Spray technology, which uses AI to accurately allow pesticide to be sprayed down to the inch, right? To make the ability to maintain your crops more efficient, also safer and healthier, using less pesticide. But they also have autonomous tractors now and other capabilities there where, yeah, they're agriculture. They have an agricultural output that's helping support the agri-food tech ecosystem overall. But AI is underpinning those efficiencies. It all brings it home to it's a horizontal technology that will improve the efficiency and performance of a variety of tech sectors. And it's no surprise that these large companies like your Amazons, your Microsofts, Teslas, and the like, John Deere's, recognize that, as I said earlier, they're digital utility. You can't effectively operate your products or services anymore to a degree without investing in what's a technological necessity like power or water to run your operations. These companies, though, choose to take that one step further and they innovate.
And something I'm curious about, and I'd love to get your opinion following the space every day over at CTA. It feels like the West, and when I say the West, you know, Canada, Australia, you know, the developed world, pretty much ex-China, Russia, and countries immediately in that influence. So it looks more and more clear every day that there's a widespread agreement to move certain things, be it TikTok, be it certain advanced chip capabilities, away from the hands of China. The CHIPS Act, we were referring to chip plants being positioned all over the world. You imagine one thought there is less concentration risk, sort of in that Pacific rim close to China. So it's appearing as though the idea of a value chain or an ecosystem that we're discussing here with all these different layers, you would almost have the China version of everything, because there is AI in China, there is data in China, it just doesn't freely flow across the border. And then you have sort of a Western version where certain countries that are clearly allies can share their data and share their technology a lot more freely. Do you sort of see a China and everything else dichotomy occurring on your side as well?
Yeah, I guess you're kind of getting into, like, is it, you know, a bad like almost like a not a hegemony, if you will, in the AI space and separate development. You know, I think innovation is going to occur no matter where. At the end of the day, right? It's going to come up separately. And like, you know, we talk about this separation starting to occur, but at the end of the day, currently, ByteDance and TikTok are still one. TikTok is still has the algorithms in the West. So you do see the impact of, I think a lot of social companies are probably looking at, well, what has ByteDance and TikTok done successfully with their algorithms at the end of the day in terms of their AI space? There's always going to be competition between, you know, powers in terms of, well, okay, maybe this is a consumer focused AI algorithm, but what about underpinning anything in our defense spaces? I'm pretty sure I know we guard our own AI advances from a government perspective from most people, including even allies, right? I think the innovation is still going to occur in China. And maybe there's some separate advances, but what's very clear is, I don't know, I think innovation doesn't really know a border at the end of the day. So I would say, sure, you're going to see some separations, and I think that's policy decision. And there's much more qualified people at CTA to talk about the policy side. But when it comes to innovation, I think China has made it very clear they're going to continue to invest in AI and in innovation there. They've had their chip plan to grow semiconductors. So we'll see that space grow. But a lot of leaps are being made in emerging markets in general, in Southeast Asia and Latin America and Africa, as well as Eastern Europe. So I think it's everything, right? We talk about, everyone pays attention to one thing usually because that's what the intention focus is. I think by focusing so much on the competition between the two, we might actually miss how much innovation is occurring greater across the board between the United States as well as China, as well as the West, as it were defined here.
So we're getting to that, final idea, final thought, final question part of the show. And we thank everyone for their time and attention. I think what we have to do is we have to at least try to get some version, some variant of the crystal ball out, and think about how tricky it is to try to make predictions on nonlinear advances in technology, recognizing that I think in the 90s there are famous stats about how much cell phone usage was expected to pick up, and they thought they were making these crazy optimistic forecasts that weren't even close to the truth at the end of the day. But it's fascinating to sort of look back and say Alan Turing was making his advances, say, in the 1940s. In the 1950s, you had Claude Shannon and John McCarthy and others, and maybe even that's where the official term artificial intelligence was itself coined. So one thing you get from that is this is not something that just in recent years has suddenly taken off. This is something that the world has been thinking about and focusing on in various ways for multiple decades. But at the same time, it takes a long time until the big advances. And maybe you think of one of those as the 2012 ImageNet, AlexNet moment, where they were able to get incredible results with the GPU. Maybe it was the invention around the transformer from Google in 2017, one of the foundational elements that allows for the T in the GPT that we tend to hear about and toss around. And then we recognize that a year ago today, we have to have the humility to say, I certainly wasn't talking about generative AI anywhere near the same degree as today. So Brian, given you're looking at the space all the time, if we're a couple of years forward, do you think we're still talking about generative AI with sort of the same excitement that we have now? Or do you think something as yet that we are unable to conceptualize, unable to predict is dominating the focus, but recognizing we're still, at the end of the day, focused on AI?
This is, man, it's fun to put the futurist hat on, right?
Yes.
Well, I definitely think AI, let's start up top. I think AI will still be in the next few years. AI in general will be front and center. I pivot back to a description that Satya Nadella, actually the CEO of Microsoft, was saying, which is he described it as the age of AI is upon us in a recent earnings call, as he labeled AI powered search the biggest thing for Microsoft since cloud 15 years ago, right? A very specific focus for him, right? Because he does have a product that's in the space. So, he's going to they have skin in the game. But at the same time, I think he's right. AI is going to be quite critical. And, you cited a lot of brilliant people in that description of like how they're viewing the future. The one I always like to throw into the equation is Christopher Freeman, a disruption economist from the UK. That's one of my favorites, which, in times of major economic downturn, he posited that innovation actually bunches up and accelerates. I think we saw that in response to SARS, in a way, if you want to go back to the early 2000s, because JD.com and Alibaba became the companies we know today in response to that. 2008 breeded really, in a lot of ways, the app economy, where you saw a lot of that innovation where Uber, Lyft, Airbnb all kind of emerged in the 08 recession. we're coming out of a pretty significant time of downturn, whether that be, it's choppy in terms of economic downturn, but I would say a social downturn, right? In terms of what the pandemic impacted. AI feels like this is the wave of disruptive innovation that we're seeing. And generative AI, I think we will be talking about in the next few years as I'm going to hedge. I'll be honest, I'm going to hedge. Maybe it's not still the central one, but it's going to be in the top 5, I think, in terms of what we're talking about as the most critical innovations in the next few years. And a lot of that is, I think we had a watershed moment. You and I talked about this really recently. For the first time, I'm someone who watches this every day. For the first time on my Twitter, I actually had to pause on an AI image. It was the generated Pope puffer jacket one. If folks saw the meme where it turned the robes into to be honest, a really cool looking puffer jacket. I had to pause and look at the hands and very closely and a little bit at the contours and zoom in. And the hands, that's where you usually can tell when generated images start to lose a little bit of their space. But a lot of people got fooled by that. I talked about digital humans earlier with South Korea deploying this in terms of their campaigns. There was a similar instance of this in Gabon, actually, where a deep fake of the president sparked fears of a coup because they were not sure, right? If those are the implications and the stakes at which you are playing with generative AI, those are some of the highest out there. I think we're going to be talking about it in a lot of ways. One, what does the innovation lead to in terms of the outputs that will help consumers today? What will it do in terms of enterprise efficiency? But also that third leg, which is what does it mean for us as a society and how do we do this responsibly? And responsible AI is going to be an undercurrent to all of this, where I think more investors are taking a look at, well, how do we build AI responsibly from an environmental standpoint, from a social responsibility standpoint, a corporate governance standpoint, so all the ESG, but also as a society in terms of our impact with one another socially, politically, financially, and economically.
Well, I think that's a great way to end it. A sprinkling of hope, a sprinkling of Black Mirror, and we'll see how the two mix as we continue to progress forward. So I want to thank everyone for tuning in today and listening to Brian Comiskey of the Consumer Technology Association, as well as myself. If you're interested in sort of keeping up with any work that Brian or I do, we have our respective company websites, the Consumer Technology Association, WisdomTree, where we're putting out a blog almost every day, publishing new content. And so do not hesitate to go to Google and search us out and find our most recent thinking. But with that, we appreciate everyone's time. Take care, and we'll look forward to seeing you again on the next big thing.